Hey guys, welcome back to AlgoYogi. We are doing binary search series, and our next problem in the list is search in rotated sorted array. So let's visit the problem on LeetCode. So there is an integer array num sorted in ascending order with distinct values. Okay, so prior to being passed to your function, nums is possibly rotated, which was a sorted array, unique values. It's been rotated. We know what rotation means. Basically, you take some elements from the back one by one each rotation and you move it to the front. Okay, we have understood that in the previous problem where we were basically searching for the minimum in a sorted rotated array. All right, so I'm sure you've gone through this whole thing about the rotation. So we have this sorted rotated array, and then we have this target. We need to find it. We have done a problem where we are given a sorted array to find this target in it. Simple binary search that we can apply. I am going to solve this problem in using basically this previous problem that we just solved, which was basically minimize, not minimize. I think the problem that we just solved was right over here. Yes, find minimum in rotated sorted array. All right, we're going to use this problem to solve it. So let's do two things. First is, what was meant, what does it mean if we know the minimum in a rotated sorted array? What does it mean? Let's switch the view here. So for now, if you haven't seen that video, please check it out, because otherwise you won't you won't get what I'm trying to say here. But simple thing is, we have this rotated sorted array. We are trying to find target here in basically big of log n time complexity. Linearly we can easily search it in big of n time complexity, but we are targeting log n. Now we have done this problem where we were supposed to find the minimum in this particular array. So if you see here, what would be the minimum over here? It would be this value. This is the minimum. This is the minimum. So tell me, if I know that this is the minimum, what does it mean? It means that there will be, before this minimum value, if there are some values, either it is completely sorted, or it is like this minimum value exists in somewhere in between. If it is like absolutely sorted, it is not rotated, or it was rotated n number of times, which is also the length of the nums. That means this is the original array which is sorted but before rotation. So if you see over here, if this value exists somewhere in the middle, then there is some sub array which is sorted in front of, before this minimum value, and including this value, there is an array that is sorted which is in the end of the basically end of the array. Initially, I'm sure this was before rotation. This array was something like this. Okay, 6 and 7, and then slowly we kept moving these values in the front, right in the front, and it ended up becoming, we took all of these values from here, Okay, maybe I could try this. So we took all of these values from here and we just rotated them and made this array look like this. Okay, so this is the array that we are searching our target right now. Target is 0. 0 is also minimum, surprisingly. So what we want to do in order to find this is look for that minimum first. And if we have that minimum, that means we could divide this array. We could divide this array into two parts. First is this, and second would be basically this. Two different arrays, and apply binary search on both of them. And whatever returns us a value, we return that as an answer. Okay, that we will return as an answer. Still, big of log n time complexity is just, we're gonna use a simple whatever code that we have written for this finding the find minimum in a rotated array. We have gone through the whole video. We understood how we basically are going to have this this bound where L is less than or equal to R, and we wrote this pseudocode. We're going to utilize its code to find the minimum, and when it returns the minimum from 0 to that minimum index -1 to that minimum to basically end of the array, these two different indexes we have, these two range of indexes that we have, these are two different sorted array, and we will apply binary search on both of them. And if it finds out the index or the answer, we will basically return that index. Okay, so let's do that. I think I'm not gonna go again how you find the minimum and how you write the binary search. This is like really easy way of writing it. So let me show you. This was the code that we wrote to find the minimum in a rotated sorted array. So let's write this over here. Okay, so if we have this particular code written, this means now we don't have to return anything. This R is the index. This R is the index of the minimum element in the array. Doesn't matter if it's either in the beginning or in the end, it doesn't matter. We will calculate basically these two ranges that we will send it inside my this helper function, and I'm just gonna call that helper function binary search. So let's call it definition BS binary search, or let's just write binary search. It's not very decent. Binary search. Okay, so binary search is going to take basically left and right pointers, left and right pointers, and that will make our job really easy. Let's find out the mid would be basically L plus R. Not right here, we forgot to compare. While left is smaller than equals to R, M would be basically left plus right, or I would rather do it left plus right minus left divided by 2, and check if nums m equals to target, then I will return the index m. Else if this target is greater than my middle, that means I need to search in the next half. So let's say if my middle is lesser than my target, right? Lesser than my target, that means I have to take my left pointer to mid plus 1, m plus 1. Now we can write the else case. Else bring the right pointer to basically first. That must have been the target is, this value is greater than target. That means we need to come to the smaller values, which will be in the beginning of the array, and that is R is mid minus 1. Bring the right pointer to before mid. Otherwise, if nothing happens, we return basically negative 1. Negative 1 could not be an index, by the way, because we are returning index, so this is a valid value to return. Okay, here let's utilize that now. Okay, so I'm not zoomed in. Let me try to zoom in so you can see the code. So this is a simple binary search helper function that I've written. This is the main part of the code where we were basically finding the minimum index, minimum number index in rotated sorted array code. array code. Okay, now this is our index that we just found. So what do? We have two different arrays. One is from basically 0 to r minus 1, and another one is r2 len nums minus 1. Okay, so there are these two ranges that we have. We're going to apply binary search on both of them, and whichever doesn't return -1 to us, that is the answer. Okay, that's where we will find out our answer. So let's store those two. So answer 1, what would be answer 1? Just call this binary search function. Let's call it on basically first range is from 0 to r minus 1, and second is basically second would be answer 2 would be from r to basically length len nums minus 1. Okay, I think this is it. Now we just need to return ans1 if ans2 equals to -1, else return ans2. This is a pretty funny way of returning. Well, anyway, we just wrote down very in a really simple way the entire code utilizing this previous code. So let's try to run it on the, I'm gonna just zoom out. I'll be so proud if it gets accepted. By the way, it runs. Awesome. Let's submit it, and I really hope it gets accepted. Great. All right, you should try this definitely. Let's write down the time complexity. Time complexity will be big of log n space complexity, space complexity would be big of constant 1. Please go through it again, go through what we talked about, having a binary search function that applies on a normal range and this list and the target, but then we found the minimum, and then we basically divided that sorted array into two different sorted parts, and we basically ran the binary search on both of them, and whichever didn't return -1, because if it didn't find the number in that portion, it will return -1. Whichever didn't return -1, that's what we returned. All right, this was really awesome. Like, I'm so happy that we wrote this solution, and I'm sure you will love it. If you're watching this video, you will love it. Please give it a like. Okay, bye-bye. So we're gonna mark this sold, and then bye-bye. See you guys later in the next problem.